Part 2. This is for questions 11 to 20. Question 11. In alkaline solution, manganate ions oxidize the sulfite ions to sulfate ions. The manganate ions are reduced to manganese 4 oxide. What is the ratio of the two ions in the balanced chemical equation for this reaction? Now, what we are going to do, we shall write the equation here. So we have manganate ions here. Then we have the sulfite ions. And then from here, we shall get sulfate and then this one here. So we have sulfate ions and then manganese 4 oxide. Yes, manganate. No. This is manganese 4 oxide. Then maybe there is something else, okay? Now, let us look at the oxidation states of manganese in here and here, also for sulfur here and here, okay? So here we shall have N, then plus 4 times negative 2, because the oxidation state of oxygen is negative 2 in here, which is equal to negative 1, the total charge here. And then N is going to be equal to negative 1, then plus what? The 8, which becomes plus 7. So here I have plus 7. And then here, what do we have? This is N plus then 2 times negative 2, then is equal to, this one is not charged, so we equate to 0, and then N becomes a plus what? 4. So here I have a plus 4. So meaning from here to there, the oxidation change, the oxidation number change is going to be a 3. It's a minus 3, but I will just write a what? A 3. So this is actually what? Reduction. Then when I look at this one for sulfur, we have N, then plus, this is 3 times negative 2, then we equate to negative 2. So N shall be equal to negative 2, then plus 6. And that one becomes a plus what? 4. So we have a plus 4 here. And then how about here? We have N, then plus 4 times negative 2, then we equate to negative 2. And then N becomes negative 2 plus 8. So for that case, N here is equal to positive 6. So we have plus 6 here. Now from here to here, that is an increase, okay, by plus 2. So increase in oxidation state is oxidation, right? Now, this is a redox reaction. When we are balancing, the change that we have in here, we switch it and multiply it here in these species that have gotten also a change in the oxidation state. So I'll put a 2 here and a 2 there. You see that? Then the change that is here, I'll multiply it in the species that have gotten this change here. So that means here I'll put a 3 and also here a 3. You see that? Then that means this is what it is supposed to be. So if there is something else that will be added, that will be that. But these are the numbers that are supposed to be there. When we look through the answers here, it has to be what? A here. Question 12. Lithium reacts with nitrogen at room temperature to form solid lithium nitride. 3 vessels of equal volume are connected by taps 1 and 2 as shown. At the start, taps 1 and 2 are closed. The left-hand vessel is evacuated. The middle vessel has the indicated reaction at equilibrium and the right-hand vessel contains lithium only. Which action could allow the equilibrium mixture to contain the most ammonia? Now, you have this equation here for ammonia, and if we look at the total number of moles here is 4, the total number of moles this side is 2. So if we want to get more ammonia, okay, using Boyle's law, P, pressure is inversely proportional to volume. Okay, so if I increase the pressure, volume will decrease. Are we there? Volume will decrease. So that means when you increase the pressure, the equilibrium is going to shift to the side with fewer number of moles. You see that? That means for that case, we also know that volume is directly proportional to the number of moles. You see? So when you increase the pressure, volume will decrease. So the equilibrium position shifts to the side with less what? Moles, because volume is directly proportional to what? The number of moles. And if the volume is down, then we go to the number of to the side with the less number of what? Gas moles. You see that? Now here they are talking about opening the taps. If we open this tap here, okay, that means the volume is going to increase. These gases here will occupy here. You see that? Even this way, they will occupy this other side. And for that case, when you open tap 1, the volume will increase. Now, when you increase the volume, okay, when you increase the volume, that means pressure will have to reduce. Are we there? So if pressure reduces, then you will go to the side with many number of moles. So the equilibrium will be shifting to this side, to the left side, meaning you will be getting less what? Ammonia. So that means where there is tap 1 open, I will cross it. Okay, so tap 1 open, it is here, so I will cross this one. Tap 1 open, I will cross it. We'll go to tap 2. If you open tap 2, okay, again they will occupy this volume here, and nitrogen is going to react with lithium. Not so? Look at this one here. Lithium reacts with nitrogen at room temperature to form solid lithium nitride. So if nitrogen reacts with this lithium, that means this equilibrium is going to be disturbed, right? So the position of equilibrium would shift to the left to replace the reacted nitrogen. Do you see that? So that means the yield, the ammonia, is going to be reduced. So in that case, tap 2 also, if it is open, this will be off. So that means our answer is actually A. You keep both taps 1 and 2 closed. Question 13. When 0.20 moles of hydrogen gas and 0.15 moles of iodine gas are heated at 723 kelvins until equilibrium is established, the equilibrium mixture contains 0.26 moles of hydrogen iodide. The equation for the reaction is as follows. This is the one here. What is the correct expression for the equilibrium constant? Okay, C. Now this is our equation. Hydrogen here reacting with iodine, then to give us 2 moles of hydrogen iodide. Okay, now at the start, at T is equal to 0, okay, we are given 0.2 moles of hydrogen. So I'll put 0.2 here, and then for iodine is 0.15. Then that means here we haven't received any, or we haven't gotten any moles of the product. And then at equilibrium, what happens? So at equilibrium, something reacts off, okay? 0.20, something reacts off. But here they are saying the equilibrium mixture contains 0.26 moles of hydrogen iodide. So this is 0.26 moles. That means something reacted off here, but when it comes this side, it multiplies by 2. You get it? It multiplies by 2. Don't you see? This is what molar ratio is 1 to 2. 1 to 2. Do you see that? So meaning that what we are going to have here, we shall get this 0.26. We divide it by 2. In other words, there is 0.13 that reacted off, but then when it came this side, because the molar ratio is 1 to 2, then it came this way as twice of it. You see that? Then we are also going to have the same thing here, 0.15 minus 0.26 out of 2. Okay, so this one will give us, this is 0.2, then you subtract 0.13, that will be 0.07, and then 0.15. When we subtract 0.13, that will be 0.02. So case C will therefore be equal to the concentration of hydrogen iodide, that is 0.26. We raise it to the power of the number of moles in the stoichiometric equation, and here we are seeing a 2, so we raise this one to power 2, and then this way times the concentration of iodine, and then the concentration of hydrogen. So we shall have the 0.07 as the concentration of hydrogen, and then the one of iodine is 0.02. And when you look through all of these answers, it has to be C. Question 14. In acidic conditions, iodine reacts with propanol in a substitution reaction. So we have this equation here. The kinetics of the reaction are investigated using a colorimeter. And that is to do with the change in the colors. Okay. As the iodine reacts, the yellow or brown color of iodine fades to colorless, changing the absorbency of the solution. Known concentrations of iodine are used to prepare a calibration curve graph, and the absorbance is then measured as the reaction proceeds. Calibration curve using known concentrations of iodine, and then we have the absorbance here. So we have the concentration against the absorbance, and then absorbance against time. Now they are saying, what is the rate of the reaction? Remember, rate of reaction is equal to concentration out of the time. Now, concentration is here, and then out of the time. But again, here we are also given the what? The absorbance. The absorbance is dependent, okay, on the concentration. Okay, so what is going to happen here? We shall begin from here. Okay, and then they said 20 seconds. Now, for 20 seconds, we shall go to this absorbance graph here. Okay, and this one is a curve. So when we are finding gradient of the curve, we draw tangents. Okay, so 20 is here. I think this 20 corresponds to this one here. So what we are going to do is to draw a tangent. Now this number was tricky because I believe most of the students here must have used this. Then they get the 0.3, and then from there, after picking the 0.3, then they come here, they look for the absorbance, which is 0.3. Okay, and then the concentration is 0.15. Then someone will say that the rate here is going to be, the concentration is 0.15. Then divide by, now the time taken, because this one is 20, then we will divide by the 20 here. Okay, and then you get it wrong. So what we can do, you draw the tangent. So this is our tangent here. Make sure that it only touches that part there. I will draw it and then take it down. Maybe like that. It only touches this point here, which corresponds to the 20. You see that? Let me in fact make it dotted so that it doesn't interfere with what was given. So after drawing that tangent, we get an absorbance here. So the absorbance is 0.4 something, maybe 0.1. So I can say maybe it's just beyond here, somewhere there. Then I can draw this one to this other side. I'm just going to approximate it to 0.1, 0.2. So the rate of the reaction, remember, is going to be equal to the concentration. So the concentration we have gotten is 0.1, 0.2. Okay, 0.2. Then divide by the time taken. Not so? The time taken. So the time taken is not going to be this 20 seconds. So when we drew this one here, this tangent, it gave us the absorbance as 0.4 something. Okay, then the 0.4 something here has helped us to get the concentration here. Okay, but this tangent here, remember, when you draw a tangent, you're supposed to get the change in y over the change in what? In x. Now the change in x here, the change in the time, is actually 40. Okay, so because it is 40 here, that now gave us the change that led us to this concentration. Then we shall divide this one by the 40. Okay, this is seconds, then this is moles per liter, so that we can have moles per liter per second as the units given there. By the way, here there is times 10 to power negative 3. Okay, so that means I'm going to add it there, and I'll say that 0.2 I've gotten, it has times 10 to power negative 3. So what does this one give us? 0.2 times 10 to power negative 3. Then we divide by 40. The answer is 5 times 10 to power negative 6. 5 times 10 to power negative 6, which is A here. Question 15. The diagram shows a Boltzmann distribution curve. The axes are not labeled. Okay. Points X and Y are points on the vertical axis. What is represented by both X and Y? Of course, for X here, it is for what we are always having here is number of molecules. Okay, number of molecules. And then this way we have energy, particular energy. We have energy here. Okay, now they're saying point X here, but then you see this dotted line up to EA. EA is activation energy. So that means that is for number of molecules with energy equal to activation energy. Okay, so let's look at this number of molecules with energy equal to activation energy, and also here. Now this one, number of molecules with energy equal or greater. No, this one is off. Or greater would be this other side. Equal, so we are beginning from here, and then this way greater. So it would be a region. You see that? So that would be that. Now that one is off. Even this one is off. Then Y. Y here, because this one is the peak. So this is the region with molecules having the average energy. Okay, with the same average energy, we call it average energy. Just like you can perform in a class, and we have that normal distribution. So there will be very few people that have gotten 30%, and very few people that are getting 70 and above. But most students can be here in the region of 40, 50, 60. You see that? So they pass averagely. So we call that the average, okay, percentage. So for this case, for the particles, we are going to have the largest number of molecules with the same energy. It has to be here. So since I'm looking at A and C, look at C. What are they saying? The amount of energy of the greatest number of molecules. No, it is largest number of molecules with the same energy. You can even see the molecules are going to be very many with this same one energy there. So that means our answer has to be A. Question 16. What are the acid-base nature and structure of sulfur dioxide? Sulfur has 6 electrons in the outermost. So when it shares with oxygen, remember oxygen needs 2. So we are going to have something like this, and there is a lone pair. So sulfur has shared 1, 2, 3, 4, right? So, and then these other 2 here. So because it has 6 electrons. Now that is that. This one is not going to be linear, because using the valence shell electron pair repulsion theory, the lone pair bond pair repulsion is stronger than bond pair repulsion. You see that? So it cannot be linear that you write something like that. It can be like that if we don't have any lone pair, just like you can have carbon dioxide, for which it can be like that. We don't have any lone pair here, so these ones will stretch themselves far apart to 180 degrees to avoid the what? The repulsions, such that the molecule can be stable. Now we come to our answers here. They are saying acid-base nature. Acid-base nature, this one has to be acidic, okay? Because these oxides of period 3 elements from what? From silicon, phosphorus, silicon, sulfur. When you dissolve them in water, you are going to form acidified what? Acidic solutions. Now, when we come to the structure, this one is a gas. That means it has a simple molecular structure. So the answer has to be B. Question 17. Elements X and Y are in period 3 of the periodic table. Element X is either phosphorus or sulfur. Element Y is either sodium or magnesium. Element X forms an oxide that reacts with water to give a solution containing the aqueous anion X, then O4 minus 2, then that one has to be sulfur. So I have to look here because we have what we call a sulfate ion. And for phosphate, we have PO4, then 3 minus. That is the anion we can get from phosphorus. But this one is a minus 2. So that one has to be what? Sulfur, strictly. So we are done with our X. Let's go to Y. 1 mole of element Y reacts with 1 mole of chlorine molecules. Remember, Y can either be sodium or magnesium. So suppose it is sodium. This is our Y. Then plus chlorine. What are you going to get? You're going to get sodium what? Chloride. So that means I can put a half here, right? And then for magnesium, then plus the chlorine, I can get magnesium chloride, like that. So it is 1 mole, 1 mole. Now, when you come to this one here, they are saying 1 mole of element Y reacts with 1 mole of chlorine molecules. At the end of the reaction, don't you think this one is even supposed to be magnesium? Because 1. Let's continue. At the end of the reaction, all of the element Y and all of the chlorine molecules have been used up. This is magnesium, because this one is a half, 1 to a half. This is 1 to 1, don't you see? So meaning our answer is going to be this one here. So we have D. Question 18. Q is a semiconductor. The chloride of Q reacts with water to form white fumes and an acidic solution. Which period 3 element is Q? Semiconductor, in period 3, we see silicon, because you have sodium here, magnesium, aluminium. These are metals. Then silicon is a metalloid. It has metallic properties and then the covalent properties. Then we also have now phosphorus, sulfur, chlorine. These ones here are non-metals. So if this is a semiconductor, that has to be what? Silicon. It has some properties of what? Metals. Question 19. V and W are 2 compounds. Each one contains a different group 2 element. Okay. A sample of each solid is added to water, shaken, and the pH of the resulting solution is measured. So for V, we have 13.6. That means this is an alkaline solution. And then for W, it is also an alkaline solution, but this one is strong, yet this one is weaker. Then which row could identify V and W? Now, solubility of group 2 metals increases down the group, increases down the group. And we are having, here we are having magnesium and barium. So magnesium hydroxide, okay, is less soluble compared to barium hydroxide. So that means when you dissolve them in water, this one is going to dissolve much more, okay? So it is going to be a stronger alkali. You will have many more oxide what? I mean hydroxide ions. So because we have many more hydroxide ions, that means barium hydroxide is a greater what? Is a strong alkali, okay? Is a stronger alkali. So for that case, then I'm going to take V for barium hydroxide, okay? The pH is too high, so I will take this as my answer. Then magnesium hydroxide with the lower solubility, we are going to have very few OH ions in solution. So the more you have the OH ions in solution, the higher is the pH. Question 20. Compound L decomposes on heating. One of the products is gas M. M reacts with unburnt hydrocarbons to form peroxyacetyl nitrate, that is PAN. What could be the formula for L? Now, this gas here that reacts with unburnt hydrocarbons, this is nitrogen dioxide. And when we look at what we are having here, it must come from a combustion of a nitrate. So we are supposed to look here and here. When you combust a carbonate, you are going to get carbon dioxide and water. You see that? I mean carbon dioxide and the oxide of the metal, like magnesium oxide here. And of course, when you even look at this one here, this one is a wrong what? Is a wrong chemical formula. This one is the correct one, but again, it is wrong. It is not going to give us what? Nitrogen dioxide. And then here, we are supposed to look at these two. So this one is the right one. Right formula. This one is wrong. Why? Because we have calcium. It has 2 plus. And then nitrate, it has a charge of -1. That means you will need 2 of these. Okay? 2 of these to balance this 2 plus. You get it 2 minus to balance the 2 plus. So you cannot have this. That means our answer has to be what? A B here.